At the end of the program, we check the rows, the columns. Now we need to check the squares. And we'll use the same idea of extracting the square, the set of digits from a square in a variable, and then checking that variable. Now the main difference is here that a square will take elements both from rows and columns. So we'll need a more a little bit more complicated method to get such a square, and we'll still return a string with all the digits in that square. So get square, and still we need the table from which we'll extract the square, but we receive both a row and a column that will be the left upper corner of the square. And what our method will do is to return a string with the digits on the specified square um, from the table. And now the table is a table as an array of strings. The top row in the square minimum value, and the left column is the square, again the minimum value of the index, and return a string with digits in the square taken on lines, so just to specify how they will be returned. Now, to create this method, it's very similar with the getColumn method. So we'll get a string that will be the result, but here we like to add all the rows from the given one, but less than all three lines, because we'll go just 3 rows down, and we'll go to the next row. And now for this row, we like to add to my result, to append to my result the substring, not only one character but several characters. So I'll take the row and I'll take a substring that will start as a column and will end as a column plus 3. So we take 3 characters from the table, and this will compute my result, so I can return the result containing all digits from a given square that has this top left corner. Now, given this get square method, now I can easily get all the squares. Now I have 3 squares, and the first one will start in row 0, and sure, I want to stop before row 9, but the squares will go from 3 to 3 lines, so I need to increment the row by 3. And to get the column, it's the same. I will start from column 0, I need to remain under 9, but I will increment the column with 3, so I will go from 3 to 3 elements to get all the values. Now, I will define a square that will get the square for my Sudoku table from the indexes R and C, and after that I can check that my square set is correct, and then I can say square the square with starting on row, and here I will write the row. So let's use the print with format because it's becoming a little bit more complicated to put all these indexes. So the square starting on row, and here I will use a %d, and column another %d contains duplicated digits. And sure, I can put these, let's put a comma, and then I'll need to provide the two parameters R and C, and that should be my code. Let's test it. Let's correct this to put first a good case like we had before. So let's run our program, and the table is partially correct. Now let's invalidate one of the squares. Let's take this bottom square. Let's put another 4 here. And you see the row is good, the column is good, but the square is not good. So let's see how this will work. If I will identify the square, yes, the square starting on row 6 and column 6 contains duplicated digits, which is correct. So our program right now checks the table, checks all the squares, and report an error message as soon as finds two duplicated digits in invalid positions. What is important in this program is that even if initially checking the rows, columns, and squares seems different, introducing a new method that was checkSet allow us to write the code, which is pretty significant, only once, and then we extract the column, we extract the square, and the row is implicitly already a string. So we extract them in a string so we can use this checkSet for all of them. So many times when you create methods, you need to do this in order not to write. Otherwise, the first solution would have been to just have 3 different methods, one to check a row, one to check a column, one to check a square, that will share this code, but checking different elements. The elements that we'll check will be not from a set, but will be various characters from either a row, column, or a square. So the code will become very difficult to understand.